For a given sequence, we can define what are called the partial sums of that sequence. So for the sequence denoted A1, A2, A3, the partial sums are, let's see, the first partial sum denoted with a capital S and a lowercase 1, or a subscript 1, is the first partial sum is simply the first term. The second partial sum, denoted S sub 2, is the sum of the first two terms, A sub 1 plus A sub 2. The third partial sum is A1 plus A2 plus A3, so you add together the first three terms. Likewise, the fourth partial sum, A sub 1 plus A sub 2 plus A sub 3 plus A sub 4. And then finally, you can denote what's called the nth partial sum. So let's write that out. The nth partial sum, and it's written like this, S sub n, and it's the sum of the first n terms. So dot 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 to A sub n. So for example, the 100th partial sum, you want to add together the first 100 terms of that sequence. All right, let's get a little practice calculating partial sums. So let's find the first four partial sums, denoted S1, S2, S3, S4, and also the nth partial sum, denoted S sub n, of the sequence A sub n is equal to 1 over 2 to the n. So like we mentioned a moment ago, the first partial sum is always the first term of the sequence. So in this case, it's just 1/2. And you can, if you want, you can write out the terms of the underlying sequence. So A sub 1 is, you don't have to do this, but A sub 1 is 1 over 2 to the first, or just 1/2. A sub 2 is 1/4, right? Plugging a 2 in for n. A sub 3 is going to be 1/8. A sub 4 is going to be 1 over 2 to the fourth, or 1/16. So the second partial sum is going to be the sum of the first two terms, 1/2 plus 1/4. And we're going to get 3/4. And likewise, the third partial sum is going to be 1/2 plus 1/4 plus 1/8. Adding those together, we get 7/8. And then the fourth partial sum is going to be the sum of the first four terms. So 1/2 plus 1/4 plus 1/8 plus 1/16. And when we add those fractions together, we get 15/16. Now the nth partial sum is going to be the sum of the first n terms. And what we want to do is basically look for a pattern based upon the partial sums we've already found. So for S sub 4, that is when n is 4, notice that the denominator here is 2 to the fourth. Likewise, for the third partial sum, notice that the denominator here is 2 to the third. For the second partial sum, it's 2 squared, and for the first partial sum, it's 2 to the first. So it looks like for the partial sums, the denominator is always going to be 2 to the n. And then likewise, look at the numerator. Do you see how it's always 1 less than the denominator in each case? So that means the numerator for the nth partial sum is going to be 2 to the n take away 1. That's what we noticed from the partial sums that we found. So this would be our answer for the nth partial sum. Let's take another example like that. So let's find the nth partial sum of the sequence A sub n is 1 over n take away 1 over n plus 1. Now we could list the first, so many terms if we wanted, but in this case it's easier to simply write out the partial sums explicitly. So let's write it out like this. Like S sub 1 we know is going to be, well, just A1, and we know that's going to be, plugging in 1, it's going to be 1 over 1 take away 1 over 2. And that can be written as 1 take away 1/2. You can simplify this, but we're going to leave it in this form because we're going to notice a pattern emerging. The second partial sum is A sub 1 plus A sub 2. And that's going to be, well, what we found a moment ago, that's A sub 1. So let's put that in parentheses, 1 take away 1/2. And then we're going to add that to A sub 2. So plugging in a 2 to find out what A sub 2 is, it's going to be 1/2 take away 1/3. Now notice that if you drop the parentheses, which you can do because it's addition, the negative 1/2 and the positive 1/2 would cancel, and you'd be left with 1 take away 1/3. And we'll leave it in that form. One more, S sub 3 is going to be the sum of the first three terms, A sub 1 plus A sub 2 plus A sub 3. And if we write that out, it's going to be 1 take away 1/2 plus 1/2 take away 1/3, and then plus, it'll be plugging in 3, 1/3 take away 1/4. And what's going to happen is everything's going to collapse. The negative 1/2, the positive 1/2, negative 1/3, positive 1/3, and you'll be left with 1 take away 1/4. And what we're seeing is that if you make a prediction of what S sub 4 is going to be, well, look what S sub 3 was, right? It was 1 take away a fourth. So it looks like this number is always one more than the index for the partial sum notation. So S sub 4 is going to be, using these as an example, 1 take away a fifth. And generally speaking, the nth partial sum is going to be 1 take away 1 over, where this number is going to be one more than that. So it'll be n plus 1 here. And that'll be the nth partial sum. Okay, and we'll go ahead in the next video, we'll go ahead and express summation, partial sums in a more compact form using what's called summation notation. Until next time.